We ready to roll, people? How about it? How about it? You got your coffee and everything? You ready to roll? Talk to a brother. Pretty good. At least 1, 2, 3 people. 2 people. I guess so. All right.
As good as we're gonna be. That's right.
I was going to say, what the hell was that? I don't speak that language. Anyway, network virtualization is 13, then we got 14, then you guys are done. It's looking like tomorrow is the electronic final. Hope you're ready. I see some people did, majority of the exams. Should try knocking out the rest of them. Don't worry about it. If the packet tracers show up as locked for you, invalid session, there's nothing I can do about that. I can't clear that. Okay? Okay. Rolling right along here. So you got network virtualization. You should be able to explain the importance of cloud computing, the importance of virtualization, describe virtualization of network services, network devices and services, describe software-defined networking, describe the controllers used in network programming. A couple of different flavors of it, but they all pretty much along the same lines, doing the same thing. Cloud computing addresses a variety of data management issues, enables access to organizational data anytime, anywhere, and at any time. Streamlines the organization's IT operations by subscribing only to needed services, eliminates or reduces the need for on-site IT equipment, maintenance, and management. Do note you got a couple of different flavors of cloud computing: SaaS, PaaS, infrastructure as a service, etc. IT as a service. Reduces the cost for equipment, energy, physical plant requirements, and personnel training needs. Also enables rapid responses to increasing data volume requirements because, look, cloud computing is kind of elastic. It grows and shrinks as you configure a need. 3 main cloud computing services defined by the National Institute of Standards and Technology, NIST. You remember I told you about them, NIST.gov. That's where you get time from in their special publication, 800.145. Or as follows. You have software as a service. Cloud provider is responsible for access to applications and services delivered over the internet. Platform as a service. Cloud provider responsible for providing users access to the development tools and services used to deliver the applications. Infrastructure as a service. This offers you the greatest degree of control over what you're doing. Cloud provider is responsible for giving IT managers access to network equipment, virtualized network services, and supporting network infrastructure. Cloud service providers have extended the model to also provide IT support for each of the cloud computing services, IT as a service. For businesses, IT as a service can extend the capability of the network without requiring investment in new infrastructure, training new personnel, or licensing new software. 4 primary cloud models. You have public clouds, cloud-based application services made available to the general population. Private clouds, cloud-based applications and services are intended for a specific organization or entity, such as the government, healthcare, etc. Hybrid clouds. A hybrid cloud is made up of 2 or more clouds. For example, part private, part public, where each part remains a separate object, but both are connected using a single architecture. Community clouds, created for exclusive use by a specific community. Differences between public clouds and community clouds are functional needs that have been customized for the community. For example, healthcare organizations have to remain compliant with policies and laws. That's the HIPAA stuff. Okay, Health Information Protection Act, that requires special authentication and confidentiality. Now, if you think that all of your medical stuff up out in the cloud is a good thing. That Brooklyn Bridge is for sale, and when the city opens, you could put a toll on it and get rich quick. Anyway, cloud computing versus having your own data center. These are the correct definitions of data center and cloud computing. A data center is typically a data storage and processing facility run by an in-house IT department or leased off-site. Data centers are typically very expensive to build and maintain. You're responsible for everything: the real estate, the climate control, the electric, the components, everything, security, everything. Cloud computing, typically off-premise service, offers on-demand access to a shared pool of configurable computing resources. The resources can be rapidly provisioned and released with minimal management efforts, so it increases your speed and agility. Data centers are the physical facilities that provide the compute, network, and storage needs of cloud computing services. Cloud service providers use data centers to host their cloud services and cloud-based resources. So understand, even if you go completely to the cloud has its own data centers, okay? Multiple data centers in a given location are typically called an availability zone, and availability zones are hosted within regions, okay? Give you a rough idea. Virtualization, the terms cloud computing and virtualization are often used interchangeably, but they're very different things, okay? Virtualization is the foundation of cloud computing. Without it, cloud computing, as it is most widely implemented, would not be possible. Virtualization separates the operating system from the hardware. Various providers offer virtual cloud services that can dynamically provision servers as required. These virtualized instances of servers are created on demand. Now, you have two types of virtualization, type 1 and type 2 hypervisors, different in the way they operate, but provide the same function for the most part. Historically, enterprise servers consisted of a server operating systems like Windows Server, Linux Server, installed on specific hardware. All of the server's RAM, processing power, and hard drive space were dedicated to the service provided, whatever it was, whether you ran web, email, DHCP, DNS, it didn't matter. And yes, you could run many different types of servers, services, daemons on one box, okay? And then they would split the load based on what service needed load, okay? Or resources, let's put it that way. When a component fails, the service provided by the server becomes unavailable, known as single point of failure. Dedicated servers were generally underused. They had a specific function for the most part, just in case there was a load, unanticipated load. Often sat idle for long periods of time, waiting until there was a need to deliver the specific service they provide. Servers wasted energy, took up more space than was warranted by the amount of service provided. This is known as server sprawl, where you open up a door and you got like a dozen freaking servers. And at any given point, there's only really 3 of them actually doing any real work. Okay? Now remember, if you look at that diagram on the side, every single service, daemon, server you run requires its own set of hardware. I say own set of hardware, it's really resources, and resources can be shared depending on who needs it, okay? Server virtualization, you got 2 different ways you could do this, okay? Right here is what it's showing is you have the hypervisor installed on top of hardware. And then within the hypervisor, you install your operating system and then your services within that given operating system, okay? And you have 2 separate servers running essentially different services that you need on the network. Like I said, server 1 is running web, email, SQL, and file services, whereas server 2 is running DHCP, Active Directory, Radius, and network management server. Each server, service, daemon running in its own operating system instance, with all instances running in the hypervisor. Server virtualization takes advantage of idle resources, consolidates the number of required servers, also allows for multiple operating systems to exist on a single hardware platform. So if you're looking at the diagram, they all show as Windows OS. They don't have to be all Windows OS. You can have a Windows OS, Linux, whatever you want in there, okay? And they can all coexist because they're all given their own set of resources as defined by the administrator. The use of virtualization normally includes redundancy to protect from a single point of failure. So that means like you have two servers. You know, out in the real world, you would have two servers for redundancy, but then you'd have two servers for every service. Ouch. The hypervisor is a program, firmware, or hardware that adds an abstraction layer on top of the physical hardware. The abstraction layer is used to create virtual machines which have access to all of the hardware and physical machine, such as CPUs, memory, disk controllers, and network interface cards, and then the hypervisor coordinates communication. One of the major advantages of virtualization is the overall reduced cost. You have less equipment because you can run multiple services inside of one hypervisor, or should I say, multiple services inside of multiple operating systems in one hypervisor, accessing one set of hardware, okay? Less energy consumed, less space required, obviously, less devices. The additional benefits of virtualization, easier prototyping, because once you take a snapshot of a device, the image, you can implement that image anywhere. Faster server provisioning, increased server uptime, improved disaster recovery, as well as legacy support. Computer system consists of the following abstraction layers. You have the services, servers, daemons. This is what's being offered to devices on the network. They utilize services. You have the operating system that the services run on, the firmware, which reaches down to hardware. At each of the layers of abstraction, some type of programming code is used as an interface between the layer below and the layer above. A hypervisor is installed between the firmware and the operating system. The hypervisor can support multiple instances of operating systems. So if you look at the diagrams there, that's pretty much what it looks like, okay? In the case of a regular server, you have the hardware, the firmware, you have the operating system that runs on top of the hardware, firmware, and then you have your services, okay? When you virtualize, you have a hypervisor that interfaces between the operating systems and the firmware. Okay, now this is typically called type 2 because you have the hypervisor installed. Actually, there's type 1 and type 2. Type 1 is bare metal. That means the hypervisor is installed directly on the hardware. And then your operating systems are installed within that. And then you have type 2, which you install the operating system on. This is called hosted, the operating system on the firmware, and then the hypervisor into the operating system. And then you can do your operating systems on top of that with your services. Type 2 hypervisor, okay? Software that creates and runs virtual machine instances. The computer on which a hypervisor is supporting one or more virtual machines is a host machine. Type 2 hypervisors are also called hosted hypervisors. Big advantage of type 2, management console software not required. So bare metal, you need management console software. Type 2, hosted, you do not, because the hypervisor is installed in the operating system that's running on the hardware. And then you install your hosted operating systems on top of the hypervisor. Type 1 hypervisors, also called bare metal approach because the hypervisor is installed directly on the hardware firmware. Type 1 hypervisor, usually used on enterprise servers and data center networking devices. The With type 1 hypervisors, the hypervisor is installed directly on the server or networking hardware. Then instances of an operating system are installed on the hypervisor as shown in the figure. Type 1 hypervisors have direct access to the hardware resources. Therefore, they're more efficient than hosted architectures. Type 1 hypervisors improve scalability, performance, and robustness because you eliminate the operating system between hardware and the hypervisor. So obviously, it's got to be more highly optimized, better performance. Installing a virtual machine on a hypervisor. Type 1 hypervisors require a management console to manage the hypervisor itself. The hypervisor management software is used to manage multiple servers using the same hypervisor. Management console can automatically consolidate servers, power on or off servers as required. These are the hosted servers in the hypervisor, okay? Management console provides recovery from hardware failure. If a server component fails, the management console automatically moves the virtual machine to another server. Cisco Unified Computing System, UCS Manager, controls multiple servers and manages resources for thousands of virtual machines. Some management consoles also allow server over allocation. Over allocation is when multiple operating systems instances are installed, but memory allocation exceeds the total amount of memory that a server has. Over allocation is a common practice because all 4 OS instances rarely require all the allocated resources at any moment in time, okay? Complexity of network virtualization. Server virtualization hides server resources. This can create problems when using traditional network architectures. Virtual machines are movable. Network administrator has to be able to add, drop, and change network resources and profiles to support mobility. Process would be manual and time-consuming with traditional network switches. Traffic flows differ from traditional client-server model. Therefore, or typically, there is considerable amount of traffic being exchanged between virtual servers. This is called east to west traffic. That changes in location and intensity over time. North-south traffic is typically traffic destined for off-site locations, such as another data center, other cloud providers, or the internet. You know, there are a lot of cloud providers out there. You have Microsoft, you have AWS, you have Google. Everybody's got their own cloud stuff that they're doing. Okay. Dynamic over-changing traffic requires a flexible approach to network resource management. Existing network infrastructures can respond to changing requirements related to the management of traffic flows using quality of service and security level configs for individual flows. However, in large enterprises using multi-vendor equipment, each time a new virtual machine is enabled, the necessary reconfiguration can be very time-consuming. Network infrastructure can also benefit from virtualization. Network functions can be virtualized. Each network device can be segmented into multiple virtual devices that operate as independent devices. So they appear as independent devices even though they're virtualized. Examples include subinterfaces, virtual interfaces, VLANs, routing tables. Virtualized routing is called virtual routing and forwarding, VRFs. This is where you can create multiple named tables inside of a device that are not seen from the main routing table. Software-defined networking. Take 10 seconds, take 10 breaths. This way I can take a pull on my crack pipe here. Oh. Everybody good so far? Any questions? Can't exactly see that text box all the time, the chat box. Is everybody good so far? No questions? Moving right. I even think you guys are there. I think you guys log in, you say hello in the morning, and you bounce and go shopping for toilet paper for cats or something.
Oh, no, we are here.
You're here?
Yes, we're here.
You're here.
Okay, I am here.
You're the designated leader? Is
Oh,
there
no.
an individual person designated as the person that responds when I'm like, are they even here? And I hope they're paying you if that's the case. We're here? Okay. I guess a couple of you here. Anyway, software-defined networking now. Then we'll go into automation in the next one. Oh my God. A network device contains the following planes: control plane, data plane. There's also a management plane, okay? Okay. Control plane, typically regarded as the brains of the device, used to make forwarding decisions. Control plane contains layer 2 and layer 3 route forwarding mechanisms, such as routing protocol, neighbor tables, topology tables, IPv4 and IPv6 routing tables, spanning tree protocol, the ARP address resolution protocol table. Information sent to the control plane is processed by the CPU. Then you have the data plane, also called the forwarding plane. This plane is typically the switch fabric connecting to the various network ports on a device. The data plane of each device is used to forward the traffic flows. Routers and switches use information from the control plane to forward incoming traffic out the appropriate egress interface. Information in the data plane is typically processed by a special data plane processor without the CPU getting involved. So the data plane uses the control plane for its decisions. The decisions have already been made by the CPU, so you don't need the CPU for the actual forwarding. Cisco Express forwarding is an advanced layer 3 IP switching technology that enables forwarding of packets to occur at the data plane without consulting the control plane. Why? Because Cisco Express forwarding copies the IP routing table, which is in the control plane, down into hardware, and it becomes the forwarding information base. Once the forwarding information base exists in hardware, an adjacency table is created with all of the packet rewrite information for each next hop contained in the forwarding information base. Now, software-defined networking, basically the separation of the control plane and data plane. Control plane function is removed from each device and performed by a centralized controller. The centralized controller communicates control plane functions to each device. Each device can now focus on just forwarding data, while a centralized controller manages data flow across multiple devices, increases security, and provides other services. Now think about it. The way that typical routing and switching happens is that each device makes its own decision, okay? With software-defined networking, when you remove the control plane from each device and host it centrally on some type of controller or server, that device now knows what all devices below it look like and can more efficiently coordinate the flow of traffic through multiple devices rather than having each device make its own decision. The management plane is responsible for managing a device through its connection to the network. Network administrators use applications like Secure Shell, TFTP, Secure FTP, Secure Hypertext Transfer Protocol to access the management plane and configure a device. The management plane is how you have accessed and configured devices while you've been studying networking. In addition, protocols like SNMP use the management plane because it's a management protocol. You see, it says management right in the name. Two major network architectures have been developed to support network virtualization. You have SDN, software-defined networking, This comes in quite a few flavors. Software-defined WAN, software-defined this, software-defined the other thing, but in general, software-defined networking. Network architecture that virtualizes the network, offering a new approach to network administration and management that seeks to simplify and streamline the actual administration process across multiple devices. Think about it. You know, how have you been doing your labs? You got to configure each and every device independently. Well, this allows you to configure multiple devices in unison almost. Cisco Application-Centric Infrastructure, ACI, purpose-built hardware solution for integrating cloud computing and data center management. Some of the components of SDN are OpenFlow. The approach was developed at Stanford to manage traffic between routers, switches, wireless access points, and a controller. Excuse me. The OpenFlow protocol is a basic element in building software-defined networking solutions. You have OpenStack. This approach is virtualization and orchestration platform designed to build scalable cloud environments and provide an infrastructure as a service solution. OpenStack, often used with Cisco ACI. Orchestration in networking is the process of automating the provisioning of network components such as servers, storage, switches, routers, and applications. You have some other components. You have interface to the routing system, I2RS, Trill, transparent interconnection of lots of links, Cisco Fabric Path, FP, and IEEE 802.1AQ, SPF, SPB, shortest path bridging. Traditional software-defined networking architecture, when you look at it, on the left is the way it was. Every device made its own decision. On the right is what it's turning to. It is now, and is on a large scale, turning to very quickly. One device makes the decision for multiple devices below it. So in a traditional router or switch architecture, the control and data plane functions occur in the same device. Routing decisions and packet forwarding are the responsibility of the device operating system in SDN. Management of the control plane is moved to a centralized controller. So if you look at the figure, it shows you the difference between the two. Okay, so you use like OpenFlow protocol between the SDN controller and the managed devices below it. So you can more effectively create flows of traffic through multiple devices rather than the time-consuming and resource-intensive process of each device making its own decision based on any given set of criteria at any given millisecond in time. The SDN controller is a logical entity that enables network administrators to manage and dictate how the data plane of switches and routers should handle network traffic. It orchestrates, mediates, and facilitates network communication between applications and network elements. The complete SDN framework shown in the figure, note the use of application programming interfaces, APIs, okay? Those are northbound. Then other stuff happens southbound, okay? So you have APIs, application programming interfaces, standardized definition of the proper way for an application to request services from another application. SDN controller uses northbound APIs to communicate with the upstream applications. This helps administrators shape traffic and deploy services. The SDN controller uses southbound APIs to define the behavior of the data planes on downstream switches and routers. OpenFlow is a widely implemented southbound API. Different types of controllers out there. The SDN controller defines data flows between centralized control plane and the data planes on individual routers and switches. Each flow traveling through the network has to first get permission from the software-defined networking controller. which verifies the communication is permissible according to a network policy. All complex functions are performed by the controller. The controller populates flow tables. Switches then manage the flow tables in a pipeline fashion. Switch to switch to switch to switch. Okay? Now, what's TLS? Somebody tell me. I ain't nowhere. I'm gonna sit here and puff on my pipe until somebody tells me what TLS is.
It's like the newer form of SSL, and it's
You the man, transport layer security.
mm,
Yay. It's good to know I've had some kind of impact, even though you probably read that without me even being involved. Anyway, it's nice to know you guys actually doing the work. I was getting worried there. I was thinking you were starting to fall off because of, wait a minute, let me check something before I go opening my dumb mouth. Okay, there ain't nobody here I got to worry about because of the bullshit that's going on with the job development. But do understand, okay? If you're doing what you need to do, okay, when we come back from this bullshit that we are all currently living, there's gonna be freaking jobs out there, I guarantee it. But you got to be doing your part now so that when you do get the interviews, and you will get interviews, you'll kill them. You'll kill the interview. Okay? That's a critical factor. There are a lot of people ain't coming back to work no more. I guarantee it. There's going to be a lot of jobs out there. And even though, you know, whatever's going on with job development and everything right now at this point in time for you guys, you know, look, you really got to worry about somebody else trying to get you a job. That's your primary function in life, is feeding yourself. So if the job developer ain't doing his end of the deal, or he's not able to do his end of the deal, who knows? Maybe he kicked the bucket from COVID. I can't say. I have no part in that. But if you guys are doing your work, when we come out of this bullshit, you'll be all the better for it, because you'll be ready to fill a job, Okay? Anyway, within each switch, a series of tables is implemented in hardware or firmware used to manage flows of packets through the switch. To the switch, a flow is a sequence of packets that matches a specific entry in a flow table. Okay? There are 3 tables as shown in the previous figure. You have a flow table, a group table, and a meter table. The flow table matches incoming packets to a particular flow and specifies functions to be performed on the packets. There may be multiple flow tables that operate in pipeline fashion. That means one switch to the next switch to the next switch. They all are switching those packets the same way because they match a specific flow. Group table, a flow table, may then direct a flow to a group table, which can then trigger a variety of actions that affect one or more flows. You have a meter table, triggers a variety of performance-related actions on a flow, including the ability to rate limit the traffic. You know, I mean, look, when all of your switches are acting in unison to move traffic, it reduces congestion because everybody knows, look, something's about to, we need to just slow this down, or we can speed it up. We can increase the size of, we can modify window sizes, stuff like that, okay? 3 core components of the ACI architecture. What is ACI? We just said that, right?
no, we just said TLS.
No, I mean, before that, we covered ACI. We talked about ACI. What is it? Eccentric. I ain't telling you. Go back a few slides. We just hit it. Application Network Profile is AMP. Collection of endpoint groups, EPGs, their connections and policies that define those connections. You have the Application Policy Infrastructure Controller. Cisco's version of that is APIC EM, the Enterprise Module. Application Policy Infrastructure Controller, Enterprise Module. APIC, centralized software controller that manages and operates a scalable ACI clustered fabric, designed for programmability and centralized management, translates application policies into network programming. You have Cisco Nexus 9000 series switches provide an application-aware switching fabric, and work with Epic to manage the virtual and physical network infrastructure. Epic is positioned between the application network profile and ACI enabled network infrastructure. The Epic translates the application requirements into network configuration to meet the needs. Why aren't they what? Why aren't they coming back? Who coming back? Who are we talking about?
Oh, that's an old post.
An old post? I see. Why aren't they coming back here? From somebody to everyone, Calvin to everyone. What are we talking about? The job developers?
Yes.
Oh, I really couldn't tell you. I'm not sure. All right. I don't know if somebody got sick and, caught COVID or whatever, or because the economy is shut down, it's difficult. Nobody's at work. It's difficult to reach people.
Oh, no.
Give out their business numbers and everything. They don't give out their personal numbers when they're not at work, and everybody's pretty much working from personal numbers right now. You know what I mean? So it may be difficult for them. They may be sick. I'm not sure.
Oh,
Okay.
no, some of us were just concerned because we were interacting with him
Right.
on the last day, and we're
Right.
just concerned. That's all.
Yeah, no, I mean, look, I'm not sure. I think doesn't next week, don't you guys have like some kind of job development? Schedule?
We haven't heard anything from the admin, actually.
But I mean,
Yeah, we
what's
were
on
supposed
the-
to have it this week. We were supposed to have it yesterday.
Okay. All right. So, you know what I'm going to do? I'm going to shoot out an email and ask that, and just indicate.
All right, thanks.
Inquired
Yeah,
about
we'd
what's going
appreciate
on.
that.
Yeah, I will. I will. I firmly believe people should do their job. I'm like that. I have no problem with saying when job developers ain't doing shit for the students. I have no problem with saying that to them.
Right, and if the admin could let us know, I mean, I understand not
Yeah,
disclose
I know.
information, but we interacted with a person. I specifically sat next to him.
Right.
He was waiting for Kathy to wrap up. So if they could explain.
Well, Kathy no longer is with us.
Right, but just that right before.
That was right before this craziness happened. And I know you guys were working with Bill Cosby over there.
Right, okay,
And I'm not a fan of Bill Cosby. I mean, I like Bill Cosby. I just don't
no,
like Bill Cosby.
I am not either, but I hope like they could let us know what happened to him.
Mm-hmm.
I personally stayed with him at least 15 minutes, and I know that he was sick and he was not well.
Right.
I haven't been either.
Well, I mean, as far as that goes, they're probably not going to give you any information about that.
Okay.
I mean, they're not allowed to. Same way as we're not really allowed to tell other students about stuff that happens with students. We're just not allowed. It's the law. And it's a really stringently applied law. You know what I mean? When it comes to medical and personal stuff, it's really not our place to forward that to anybody without that person's express permission.
Okay.
I mean, so I will find out what's going on with job development, and I'll have one of the Jennifers come in someday to the meeting soon and explain what's going on with that. Okay?
Thank you. Thank you.
All right. Because I know you're stressed out. I know you're like, oh, this is going to end, and then we're like, left in the lurch. I don't think you should be, and I think you guys should have them do their jobs. We're here doing our job every day, aren't we?
Right.
Shouldn't they be? Shouldn't they be?
I'm not a fan of Cosby's, but I don't speak for the group, so yeah.
Yeah, I know. Nobody. I will. I have no problem with speaking for the fact that I'm here doing my job, to the best of my ability, given the circumstance. You guys are, even though I got to like twist your arms to get exams out of you. I understand. I have stuff I'm supposed to be doing and I'm bullshitting about it. Why? Because it's like, yeah, it'll still be there tomorrow. You know what I mean? But no, I will inquire about them and raise the red flag that you guys are concerned.
Okay, thank you.
And if they ask who was concerned, I'll tell them I ain't telling you that. I have no problem with telling them that also. I'm not telling you that. The class is concerned. There are people in the class that are concerned, and you got to address those concerns. Okay? Because I have no information on it. But I do thoroughly believe they should be doing their job. Okay? That was part of the program. They should be finding a way to get that done. Even if it's just like resume writing and interview skills and all of that, if they don't have any hard leads because the entire city is shut down, they should be prepping you on how to interview and things like that. Okay? So I'll raise those concerns. I'll send an email. Okay?
Thanks, Chris.
No problem. So, core components of ACI. Yep, that's it. You have a customer or tenant contract. Now, when you look at a customer or tenant contract, you're going to read about with all kinds of virtualization and software-defined networking, information about tenancy. Tenancy is like this. There are a lot of organizations that are not allowed to share, even if they're using cloud computing services, software-defined networking. They are not allowed to share any single device that data is stored on. Okay? So you may be in an organization that requires single tenancy servers. That means you have dedicated use of that server. Even if it is in the cloud, it's single tenancy. And then there are other organizations that aren't bound by all of these restrictions and laws that can actually share the same server as other users. Even though your tenancy can't see their tenancy objects, information, you can still be on the same server, multi-tenancy, different customers on one piece of hardware. And then you have organizations bound by law that have to have single tenancy, which is where it is a dedicated piece of hardware for them. Okay, so that's how tenancy goes. Then you have VLANs. VLANs can be separate tenants inside of a VLAN. You have VMware, web services, applications, and databases, and they all run contingent upon what your tenancy scheme is. Cisco ACI Fabric, you have spine leaf, okay? So the spine, like the backbone, and then the leaves, all right? Now with that spine leaf topology, every device is no more than one hop away from another device. ACI Fabric is composed of APIC, Application Policy Infrastructure Controller, and a Nexus 9000 series switch using two-tier spine leaf topology. As shown in the figure, leaf switches attach to the spines, but they never attach to each other. Similarly, spine switches never attach to spine switches, only attach to leaf, and core switches. The core switches are not shown. They're above the spine switches, okay? In this two-tier option, everything is exactly one hop from everything else when compared to SDN. The APIC controller does not manipulate the data path. Instead, the APIC centralizes policy definition and programs leaf switches to forward traffic based on the defined policies. Cisco Application Policy Infrastructure Controller Enterprise Module, APIC EM, extends ACI aimed at enterprise and campus deployments. To better understand APIC EM, it's helpful to take a broader look at the three types of SDN. You have device-based SDN. The devices are programmable by applications running on the device itself or on a server in the network as shown in the figure, okay? And you have things like 1PK utilizing OpenFlow down to the data plane on the leaf devices. Controller-based SDN uses a centralized controller that has knowledge of all devices in the network as shown in the figure. The applications can interface with the controller responsible for managing devices and manipulating traffic flows throughout the network. Cisco OpenSDN controller is a commercial distribution of Open Daylight. Policy-based SDN, similar to controller-based SDN, where a centralized controller has a view of all devices in the network, as shown in the figure. Policy-based software-defined networking includes an additional policy layer that operates at a higher level of abstraction, uses built-in applications that automate advanced configuration tasks via a GUI, a guided workflow, and a user-friendly graphical user interface, GUI. In this case, no programming skills are required. Why? Because it's like, it's software driven. It's, an interface tells you, okay, you did this, do that. You did that, do this. APIC EM is an example of this type of SDN. APIC EM provides a single interface for network management, including discovery and accessing device and host inventory. So it'll give you a full read. Look at the diagram on the right, tell you what everything is. Viewing the topology as shown in the figure, tracing paths between endpoints and setting policies. So with the APIC EM, you can actually do end-to-end ACL testing to see if any given device in a path has a problem with an ACL on another device. The APIC EM Path Trace tool allows administrators to easily visualize traffic flows, discover any conflicting, duplicate, or shadowed ACL entries. The tool examines specific ACLs on the path between two end nodes, displays any potential issues. You can see where any ACLs along the path either permitted or denied your traffic as shown in the figure. Notice how branch 2 router is permit all traffic. The network administrator can now make adjustments if necessary to filter traffic or better filter traffic. So you see up there, there's your ACL on that device. I know it's a little rough to see, but if you can magnify it, you might get a little better permit IP any, all that good stuff. Look at that, we're done with this one. We're gonna get a vape break in a couple of minutes. Cloud computing involves large numbers. I know you guys were hoping for a lab or something so you could buy yourself a half hour to go and goof off. Cheese, whatever. But there are no labs in this one or the next, okay? So it'll give you time to catch up on exams and other packet tracer labs that you might not have completed. I highly recommend that you just do it. Just do it. What else you got to do, really? You can pet your cat at the same time and type with one hand. Cloud computing involves large numbers of computers connected through a network that can be physically located anywhere. Cloud computing can reduce operational costs by using resources more efficiently. 3 main cloud computing services defined by the NIST, National Institute of Standards and Technology: software as a service, platform as a service, and infrastructure as a service, okay? You also have information technology as a service. The 4 types of clouds are public, private, hybrid, and community, okay? Virtualization is the foundation of cloud computing, separates the operating system from the hardware. 2 ways of doing it. You got bare metal, the hypervisor is installed right on the hardware, and then you have hosted. The hypervisor is installed in an operating system installed on the hardware. Virtualization reduces costs because less equipment is required, less energy consumed, less space is required. Provides for easier prototyping, faster server provisioning, increased server uptime, improved disaster recovery, and legacy support. Now, look, when you look at that one line, that line says a lot. It really does, okay? Where you once had an entire room of equipment that you then had to cool that room, you lost real estate because they're usually not small rooms, okay? You paid for electricity because you had to power the device, and then you had to power climate control to cool the devices, and you had to secure it. All right, so think about it. It saves a lot. With type 1 hypervisors, the hypervisor is installed directly on the server networking hardware. The hypervisor is software, creates and runs VM instances, can be installed on top of the OS or installed between firmware and the OS. Okay, if it's installed between firmware and the OS, it's type 1 bare metal. If an operating system is installed on the firmware and hardware, that is a hosted approach. Type 1 hypervisor is also called bare metal approach because the hypervisor is installed directly on the hardware. Type 1 hypervisors have direct access to hardware resources and are more efficient than hosted architectures. The reason for that is the hypervisor is the interface between each virtual machine's allowed hardware, because you have to configure what the virtual machine has access to, how much memory, how much disk space, etc. Okay? When you install an operating system on the hardware and then install the hypervisor in the operating system, you have to bridge that operating system's use of the hardware to the virtual machine, which is less effective. All right? They improve scalability. Wait a minute. Yeah, that's right, because the hypervisor is installed directly on hardware. Type 1 hypervisors have direct access to hardware resources and are far more efficient than a hosted architecture. They improve scalability, performance, and robustness because you don't have that operating system in the way. Type 1 hypervisors require a management console to manage the hypervisor itself because you don't have an operating system. Server virtualization hides server resources, such as the number and identity of physical servers, processors, and operating systems from server users. You only see the hosted server, the VM server. You can't see what server it's running in. The practice can create problems if the data center is using traditional network architectures. Traffic flows in the data center differ substantially from traditional client-server models. Typically, a data center has a considerable amount of traffic being exchanged between virtual servers. That's east to west, server to server in the device, and can change in location and intensity over time. North-south traffic occurs between distribution and core layers. Typically, traffic destined for off-site locations, such as another data center or other cloud providers or the internet. Two major network architectures have been developed to support network virtualization. You have software-defined networking and Cisco application-centric infrastructure is what the ACI was. Components of SDN may include OpenFlow, OpenStack, as well as other components that are used. A network.
Ah.
Yeah. What?
Oh, did you just skip way ahead or something, or?
No.
Oh, okay. Sorry.
OpenFlow, OpenStack, and other components, and then we're right here. Okay. A network device contains control and data plane, also contains a management plane. Control plane is regarded as the brains of the device. This is where your routing and switching tables exist. Now, whether or not they're copied down into hardware and used differently, the way, Cisco Express Forwarding brings down a copy of the routing table into hardware and it becomes the forwarding information base, and then you build an adjacency table with all the packet rewrite information for the next hop, each next hop found in the forwarding information base. Remember, switches do their work in ASICs also. Application-specific integrated circuitry. Software, slow. Control plane, software. Hardware, fast. Data plane, fast. Okay? The SDN controller. Wait a minute. SDN is basically the separation of control plane and data plane. Control plane function is removed from each device and performed by a centralized controller. The SDN controller is a logical entity that enables network administrators to manage and dictate how the data plane of switches and routers should handle network traffic. The data plane, also called the forwarding plane, typically the switch fabric connecting the various network ports of the device used to forward the traffic flows. The management plane is responsible for managing a device through its connection to the network. You know, SSH, HTTPS, whatever. The SDN controller is a logical entity, enables network administrators to manage and dictate how the data plane of switches and routers should handle network traffic. Cisco developed the application-centric infrastructure, ACI, which is more advanced and innovative than earlier SDN approaches. Cisco ACI, application-centric infrastructure, hardware solution for integrating cloud computing and data center management at a high level. The policy element of the network is removed from the data plane, simplifies the way data center networks are created. 3 core components of ACI: application network profile, application policy infrastructure controller, and a Nexus 9000 series switch. Cisco ACI fabric is composed of the APIC and Nexus 9000 switch using a 2-tiered spine leaf topology where every device is no more than 1 hop from every other device. When compared to the SDN, the APIC controller does not manipulate the data path directly. Instead, the APIC centralizes the policy definition and programs the leaf switches to forward traffic based on defined policy. 3 types of SDN. You have device-based SDN, controller-based SDN, and policy-based SDN. Policy-based SDN includes the additional policy layer that operates at a higher level of abstraction. Policy-based SDN is the most robust, providing for simple mechanism to control and manage policy across the entire network. The APIC EM is an example of policy-based SDN. APIC EM provides a single interface for network management, including discovering and accessing device and host inventories, viewing the topology, tracing paths between endpoints, and setting the policies on paths. The APIC EM paths and flows, okay? APIC EM path trace tool allows the administrator to easily visualize traffic flows and discover any conflicting, duplicate, or shadowed ACL entries that may cause problems. Tool examines specific ACLs on the path between 2 end nodes, displaying potential issues. Ta-da! That one done. Any questions about any of that? Yes, no, maybe. I'll take that to be a no. It's 10:47, 11:02. We'll pick up and start looking at the other one, okay? Chapter 14, after the NAC, no questions, okay. So what was that? That was chapter 13, module 13. So module 14, after a vape break, okay? So 15 minutes. So figure about it's what, 10:48? About 5 or 10 after 11, we'll get started on the other one. Good deal? Yeah, that was a mouthful, wasn't that one? All right, so
Actually, I do have a question regarding virtual.
did somebody just say bullshit?
No.
Or did somebody sneeze?
I had a question actually regarding all this virtualization. Is there a weakness? Like, is there a con about it? Like,
No,
how to
actually, there aren't any real problems because you do integrate security in this. The good thing is, see, look at it like this. The controller, let's say, when you move the control plane from each device to a centralized controller, the primary security point is the controller. The devices are not making the decisions directly, so as long as the protocols used to coordinate flows through multiple devices is secure, then your network is still secure. You'll still have to do basic security on each device, but by centralizing operations, you have less points of entry for people to do the nasty. Does that make sense?
Yes, sir. Thank you.
I don't think that made sense. You didn't sound convincing with that. Yes, sir.
Kind of. I think I need to do a little more research
A
on
little
that.
bit of research, because remember, when you configure 30 routers, you have 30 points of entry. Any one of them that has any kind of, security, how would you put it? Lacks security implementation. In other words, somebody just forgot to do something. All right, with 30 routers versus one controller, where do you think you come off better? Because with the 30 routers or switches using a centralized controller, it's basic security at that end, because they're not making any routing or switching decisions independently. The controller is making them for them. So you have a centralized point that you need to secure, and then just secure the protocols basically, which they do. They use TLS, et cetera, to communicate with each other. So rather than having to fully secure 30 different devices, basic security on the 30 and then full security on the centralized device. Does that help?
Yes, thank you. That was very clear. Thank you.
All right.
I
Plus,
appreciate
the
it.
controller itself can tell you if there are any security problems on any of the 30 devices it's managing. You know what I mean? So it's a much better read of what's going on the network.
Got it. Thank you.
Okay. So module 14 in about 10, 15 minutes. All right. What? Hold on. Are we ready? Or do you need a couple of more minutes? I guess a couple of more minutes it is. Couple of more minutes works. This is the last module, so after this, it's just exam catch up. Anybody that's got to finish out a hands-on final or packet traces. All right, we ready to roll? Okay. Network automations. So this is not virtualization, it's network automation. I'll fix that one of these days. Should it be able to explain? No. Software, what the hell? Something wrong with this? Automation. Okay, there you go. First slide or two, not quite right, but it is software-defined networking when you're dealing with automation, so we'll leave that slide alone. Some of the benefits to automation: machines work 24 hours a day without breaks, results in greater output. Machines provide a more uniform product. Automation allows the collection of vast amount of data that can be quickly analyzed to provide information and help guide an event or process. Robots used in dangerous conditions such as mining, firefighting, cleaning up industrial accidents, which reduces the risk to humans. Under certain circumstances, smart devices can alter their behavior to reduce energy usage, make medical diagnosis, and improve automobile driving safety. Personally, I think that's the driver's problem, because some of you guys shouldn't be driving. I've seen you. Anyway, thinking devices. Many devices now incorporate smart technology to help govern their behavior. Can be as simple as a smart appliance lowering its power consumption during periods of peak demand, or as complex as a self-driving car. Whenever a device takes a course of action based on an outside piece of information, then that device is referred to as a smart device. Many devices we interact with now have the word smart in their name: smart TV, smartphones. Many devices, this indicates that the device has the ability to alter its behavior depending upon its environment. In order for devices to think, they need to be programmed using network automation tools. Data formats. Now, this is going to get freaky. It might be scary to some people because, look, this is kind of like programming. It's not programming. It's scripting, more or less, which is programming. Data formats concept. Data formats are simply a way to store and exchange data in a structured format. One such format is called HTML, hypertext markup language, which is a standard markup language for describing the structure of web pages. There are others: DHTML, XML, ASP. There are all kinds of languages out there. These are the common data formats used in many applications, including network automation and programmability. You have JSON, JavaScript, object notation. Relatively simple, straightforward. I won't say it's easy. Everything that you do requires some type of learning curve. You have extensible markup language, XML, and you've got YAML. And all YAML means is YAML ain't markup language. The Y, the A, the M, the L. YAML ain't markup language. The data format that's selected will depend on the format used by the application tool or script you're using. Many systems will be able to support more than one data format, which allows the user to choose their preferred one. Kind of makes it a little easier on you. Data formats have rules and structure similar to what we have with programming and written languages. Each data format will have specific characteristics. Syntax includes types of brackets used, such as squared brackets, parentheses, braces, the use of white space. That means, just simply pressing the space bar, or indentation, quotes, commas, and more. Do note, indentation typically makes programming languages easier to read. You generally have a container And in that container, you configure things or specify actions. Now, the container itself is at the high level. It's on the outside. It's like a parent. And then what you specify is like a child object inside of the container. When you indent correctly, it makes the code far easier to read. Okay, because it begins to make sense when you indent it appropriately. Okay, how objects are represented, such as characters, strings, lists, arrays. Array is simply a list of things that belongs to a given array. How key value pairs are represented. Key is usually on the left side, identifies or describes the data. The value on the right is the data itself, can be a character, string, number, list, or another type of data. Okay, so here you see in quotes, message, colon, success, comma, timestamp, colon, the value for the timestamp, comma, ISS underscore position, and this would be geo positioning, which is latitude, colon, the latitude, longitude, colon, the longitude. Different formats, you have JSON, YAML, XML. Take a peek at those for a second or two. Close, aren't they? The difference is, okay, so JSON uses quotes. YAML uses single quotes rather than double quotes. Some stuff isn't even quoted. Less braces, etc. Okay. And then XML. That's more like a markup language, like HTML. Markup languages typically have an opening phrase. Let's say value, not value, the value in, if you look at message inside of the left and right shift characters, success is the value. The open, or should I say less than sign, greater than sign, that encapsulates the message parameter. Success is the value. And then you close the parameter with a less than sign, / message, greater than symbol, or left shift, right shift, or what they are actually called in programming. So if you're looking at the mouse, this is a left shift. This is a right shift character in programming. And you open and close values by using the opening tag / the closing tag for that field, that value, which is success in this case. Okay. JSON, human readable data format used by applications for storing, transferring, and reading data. JavaScript object notation, very popular format used by web services and application programming interfaces to provide public data. This is because it's easy to parse, can be used with most modern programming languages, including Python. The way that it works. Here you see an interface, right? G000 is up, line protocol up, connected, description, wide area network, the internet address, 172.16.0.2/24. So when you look at it, compare the iOS output above to the output in the JSON format. Notice each object, each key value pair is a different piece of data about the interface, including its name, description, and whether it's enabled. So there you see IETF-interface : interface : open brace, the name, in double quotes, : and in double quotes again, gigabit Ethernet 0/0/0, the description in quotes, : wide area network. Enable is true, that means the interface should be up. IETF IP, : IPv4, the address. The IP is 172.16.0.2 and the net mask is 255.255.255.255.0. Okay, so a script like this could be used to go out on a given device locate gig 000, give it a description of wide area network, and issue the no shut command and assign the IP address of 172.16.02 with a 24-bit mask, okay? These are some of the characteristics of JavaScript object notation. Uses a hierarchical structure, contains nested values, uses braces to hold objects and square brackets to hold arrays. Data is written as key value pairs. So when you look at it, net mask is a key. The subnet mask is the value. IP is the key. The IP address is the value, okay? And they are nested. Notice the opening brace is far left. That's parental. This IETF interface, interface, is parental. The name, gig 000, that's a child parameter. Description, wide area network, child parameters. You get the idea. With JSON, data is known as an object. There's one or more key value pairs enclosed in braces. JSON, for a JSON, the syntax for a JSON object includes keys, must be strings with double quotation marks. Values must be a valid JSON data type, string, number, array, Boolean, null, or another object that you're referencing. Keys and values are separated by a colon. Multiple key value pairs within an object are separated by commas. White space, not significant. So if you're looking here, all of this white space does not matter. At times, a key may contain more than one value. This is known as an array. An array in JSON is an ordered list of values. Characteristics of arrays in JSON include the key followed by a colon and a list of values enclosed in square brackets. The array is an ordered list of values. The array can contain multiple value types, including a string, number, Boolean, object, or another array inside. Each value in the array is separated by a comma, excuse me. For example, a list of IPv4 addresses might look like the following output. The key is addresses. Each item in the list is a separate object, separated by braces. The objects are two key value pairs, an IPv4 address, IP in quotes, double quotes, and a subnet mask, net mask in double quotes, separated by a comma. The array of objects in the list is also separated by a comma, the following the closed brace for each object. So here you have the addresses, open squared bracket, open brace. You have an IP as 172.16.02 with the net mask of 24 bits. Close brace, comma, open brace, another value, 1603 with a 24-bit mask. Close brace, comma, open brace, 1604 with a 24-bit net mask, close brace. Now, here is the thing. You match these. Oh, man, I clicked on it. Look, this brace refers to this brace. You open a brace, you must close the brace. If you open a bracket, you must close the bracket. Open brace, close brace, open brace, close brace, open brace, close bracket, because the bracket is the address array. Hope that makes sense. YAML. YAML ain't markup language. Another type of human readable data format used by applications for storing, transferring, and reading data. Some of the characteristics of YAML include, it's like JSON, considered a superset of JSON. Remember, subset is partial. Superset, more comprehensive. It has a minimalist format, making it easy to both read and write. Uses indentation to define its structure without the use of brackets or commas. Note here the use of brackets and commas and indentation, okay? When you look at YAML, it's a little different. iOS output in JSON is to the left. Same data in YAML format is below, and it's much easier to read when you think about it. Similar to JSON, a YAML object is one or more key value pairs. Key value pairs are separated by a colon without the use of quotation marks in YAML. A hyphen is used to separate each element in a list. So if you're looking at this over here, this looks more like programming than this does. This kind of looks like, the way you would document something, and it looks cleaner. Okay, this looks like programming, and it looks like a pain in the ass. Okay, so there's your differences between YAML and JSON. The XML data format, you're familiar with this. You've seen web pages in XML and ASP and all of that good stuff. XML, one more type of human readable data format used to store, transfer, and read data by applications. Some of the characteristics of XML: extensible markup language. It's like HTML, which is standardized markup language for creating web pages and web applications. Self-descriptive, encloses data with a related set of tags. Unlike HTML, XML uses no predefined tags or document structure. HTML does, okay? When you build a web page, it's very specific. This is a little different, a little looser. XML objects are one or more key value pairs with the beginning tag used as the name of the key, okay? So you have key, the value, and then you have to close that key with the / key value, key name, I mean. The data format, look at that. Look, open up a web page, right click on the web page. If it's an HTML web page, and click view source. It looks exactly like this, basically. The output shows same data for gigabit Ethernet 2, formatted as XML data structure. Notice how the values are enclosed within the object tags. In this example, each key value pair is on a separate line. Some lines are indented, not required, but done for readability. List uses repeated instances of open tag, close tag. For each element in the list, the elements within these repeated instances represent one or more key value pairs. So you see there, you have same old stuff. Look, XML, blah, 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 IETF-interfaces, :interface, the name, gig Ethernet 2, closed name, description, wide area network, closed description, enabled, true, close enabled, the address, mask, etc. Okay, just so you have a rough idea. APIs, application programming interfaces. An API is software that allows other applications to access its data or services. It's a set of rules for describing how one application can interact with another, and the instructions to allow the interaction to occur. The user sends an API request to a server asking for specific information and receives an API response in return from the server along with its requested information. An API is similar to a waiter in a restaurant as shown in the following figure. You have the user, the customer. They interface with the waiter interfaces with the kitchen interfaces with the waiter then interfaces with the customer, okay? So your API is used to make your requests and return the responses. To really understand how APIs can be used to provide data and services, look at two options for booking airline reservations. The first option uses the website of a specific airline. Using the airline's website, the user enters information to make a reservation request. Website interacts directly with the airline's database and provides the user with information matching what they requested, okay? A travel site can access the same information, not only from a specific airline, but a variety of airlines. In this case, the user enters in similar reservation information. The travel service website interacts with various airline databases using APIs provided by each airline. Travel service uses each airline API to request information from that specific airline, and then it displays the information from the airline on its web page. The API acts as a kind of messenger between the requesting app and the app on the server that provides the data or service. The message from the requesting application to the server where the data resides is known as an API call. Open, internal, and partner APIs. An important consideration when developing an API is the distinction between open, internal, and partner. Open APIs or public APIs. APIs that are publicly available can be used with no restriction. Because the APIs are public, many API providers require the user to get a free key or token prior to using the API. This is to control the number of API requests they receive and process. Internal or private APIs. These are APIs that are used by an organization or company to access data and services for internal use only. An example of an internal API is allowing authorized salespeople access to internal sales data on their mobile devices. You have partner APIs. These are APIs that are used between a company and its business partners or contractors to facilitate business between them. The business partner must have a license or other form of permission to use the API. A travel service using an airline's API is an example of a partner API. Types of web service APIs. A web service is a service available over the internet using the World Wide Web. 4 types of web service APIs. You have simple object access protocols, SOAP, representational state transfer, which is REST, extensible markup language, RPC, remote procedure call, which is XML RPC, and JavaScript object notation, RPC, remote procedure call. So this is the way that they go. Look at the table down below and see their timelines and all of that good stuff. The data format for XML, you got SOAP, 98. It's well established, been around for a long time. REST, JSON, XML, YAML, and others, 2000. Flexible formatting. These are the most widely used because of their simplicity and flexible formatting. Okay, you have XML RPC. XML is the flavor there, 98, well established, has simplicity. JSON, been around for a minute, and a lot of people like JSON because of its simplicity. REST. Web browsers use HTTP or HTTPS to request, get a web page. That's a GET request. If successfully requested, the HTTP status code of 200. Web servers respond to GET requests with the next HTML-coded web page. Simply stated, a REST API is an API that works on top of the HTTP protocol. Defines a set of functions developers can use to perform requests and receive responses via HTTP protocols, such as GET and POST requests. Conforming to the constraints of the REST architecture is generally referred to as being RESTful. So they call them RESTful APIs. An API can be considered RESTful if it has the following features. Client server, client handles the front end, server handles the back end. Either can be replaced independently of the other. That means you can work on the client side of it or the server side of it. All right? Stateless. No client data is stored on the server between requests. The session state is stored on the client. And cacheable. Clients can cache response so they can improve their performance. A RESTful web service is implemented using HTTP. It's a collection of resources with 4 defined aspects. The base uniform resource identifier, URI, for the web service, such as http://example.com/resources. The data format supported by the web service, often JSON, YAML, XML, but could be any other data format that is a valid hypertext standard. The set of operations supported by the web service using HTTP methods. The API must be hypertext driven. RESTful APIs use common HTTP methods, including post, get, put, patch, and delete. As shown in the following table, these correspond to RESTful operations. Create, read, update, and delete, or CRUD is what they call. Okay? So post is create in RESTful. HTTP post is create in RESTful. Get is read in RESTful. Put, patch, update in RESTful. Delete is simply delete in a RESTful operation. URI, URN, and URL. Web resources and web services such as RESTful APIs are identified using a URI. A URI is a string of characters that identifies a specific network resource. A URI has two specializations. A URN, Uniform Resource Name, identifies only the namespace of the resource, web page, document, image, etc., without reference to the protocol itself. Uniform Resource Locator defines the network location of a specific resource. HTTP or HTTPS URLs, typically used with web browsers. Protocols like FTP, SFTP, SSH, and others can use a URL. A URL using SFTP might look like sftp://sftp.example.com. These are the parts of the URI. Okay, you see it there. You have protocol screen or scheme, HTTPS, or other protocols like FTP, SFTP, mail to NNTP, network news transfer protocol is NNTP. The host name, www.example.com. Path and file name is anything after the .com/author/book.html is the actual file. Author is the folder. Fragment. Pound, page 155, because look, when you click on certain things, I know you've done it before. You've clicked on a link inside of a document that took you to a specific section inside of another document. That's that pound, page 155. In a RESTful web service, a request is made to a resource's URI. Or a request made to a resource's URI will elicit a response. The response will be a payload, typically formatted in JSON, could be HTML, XML, or another format. Figure shows the URI for MapQuest Directions API. The API request is for directions from San Jose, California to Monterey. So when you look at it, here's what you got. You got your API server right there. That's the HTTP, whatever, mapquest.com. The resources that you're drilling down to, route, ? And then the format, key, parameters. This is the entire query, what you're asking for down here in orange. These are the different parts of the API request. You've got the API server, the URL for the server that answers REST requests. In the example, it's the MapQuest API server, okay? Resources specifies the API being requested. Now note, route with the question mark is the actual resource you're requesting. Directions /v2, that's a folder structure to the route API, okay? In the example, it's the MapQuest Directions API. Query specifies data format and information the client is requesting from the API service. Queries can include a format, usually JSON, but can be YAML or XML. In this case, it's JSON. Okay, you see it there, out format equals JSON. ampersand to bind the key, okay? Key. For authorization, if required, MapQuest requires a key for their directions API. In the above URI, you would need to replace key with a valid key to submit a valid request. Parameters used to send information pertaining to the request itself. In this example, the query parameters include information about directions that the API needs so it knows what directions to return from San Jose, California to Monterey, California. Many RESTful APIs, including public APIs, require a key. The key is used to identify the source of the request. Here are some of the reasons why an API provider may require a key: to authenticate the source and make sure they are authorized to use the API, to limit the number of people using the API, to limit the number of requests per user, to better capture and track the data being requested by users, to gather information on people using the API. The MapQuest API does require a key. Search the internet for the URL to obtain the MapQuest key. Use search parameters developer.mapquest. You can also search the internet for the current URL that outlines the MapQuest privacy policy. Many websites and applications use APIs, application programming interfaces, to access information and provide service for their customers. Some RESTful API requests can be made by typing in the URI from within a web browser. The MapQuest Directions API is an example of this. RESTful API requests can also be made in other ways. You have a developer website, Postman, Python, network operating systems, okay? Developer website. Developers often maintain websites that include information about the API, parameter information, usage examples to help you on your way. Sites may also allow the user to perform the API request within the developer web page by entering in the parameters and other information. Postman is an application for testing and using REST APIs. Contains everything required for constructing and sending REST API requests, including entering query parameters and keys. Python APIs can also be called from within a Python program. This allows for possible automation, customization, and app integration of the API. You have network operating systems using protocols such as netconf, which is actually net configuration, but we call it netconf, and restconf. Network operating systems are beginning to provide an alternate method for configuration, monitoring, and management. Configuration and management tools. Traditional network configuration. You sat at the CLI for every device, okay? Network devices have traditionally been configured by a network administrator using the CLI. Whenever there's a change or a new feature, the necessary configuration commands have to be manually entered on all the appropriate devices, which becomes a major issue on large networks or networks with more complex configurations. Traditional network configuration, when you look at it, you have a network management system station utilizing SNMP, Simple Network Management Protocol, UDP ports 161 and 162. But remember, 161 goes TCP also. Lets administrators manage nodes on an IP network with a network management station. Network administrators use SNMP to monitor and manage network performance, find and solve problems, and perform queries for statistics. SNMP, not typically used for configuration due to security concerns and difficulty in implementation. You can also use APIs to automate deployment and management of network resources. Instead of manually configuring ports, access lists, quality of service, and load balancing policies, you can use tools to automate the configurations. With network automation, we're rapidly moving away from a world where network administrators manage a few dozen network devices to one where they're deploying and managing a great number of complex network devices, both physically and virtual. With the help of software, the transformation is quickly spreading to all places in the network. There are new and different methods for network administrators to automatically monitor, manage, and configure the network. These include protocols and technologies such as REST, Ansible, Puppet, Chef, Python, JSON, XML, and a lot more. There's a whole bunch of stuff out there that you can do, okay? Configuration management tools make use of RESTful API requests to automate tasks and can scale across thousands of devices. These are some characteristics of the network that administrators benefit from automating. Software and version control, device attributes such as names, addressing, and security, protocol configurations, and ACL configurations. Configuration management tools typically include automation and orchestration. Orchestration between different devices for different flows or different programming needs, okay? So automation is when a tool automatically performs a task on a system. Orchestration is the arranging of automated tasks that results in a coordinated process or workflow. Several tools available to make configuration management easier. You have Ansible. There is a guy, Roger Perkins, on the internet. All you have to do is sign up to his YouTube, and he does Ansible classes all the time for free, okay? You got Ansible, Chef, Puppet, Salt Stack. The goal of the tools is to reduce the complexity and time involved in configuring and maintaining a large-scale network infrastructure with hundreds or thousands of devices. The same tools can benefit smaller networks also. Work smart, not hard. Ansible, Chef, Puppet, and Salt Stack all come with API documentation for configuring RESTful API requests. All of them support JSON and YAML, as well as other data formats. The following table shows a summary of a comparison of major characteristics of Ansible, Puppet, Chef, Salt Stack configuration management tools. So when you look at it, the characteristic, what programming language? For Ansible, it's Python and YAML. Chef, Ruby, Puppet, Ruby. Salt Stack is Python. Agent-based or agentless. For Ansible, it's agentless. For Chef, it's agent-based. Puppet can go both ways, so can Salt Stack. How are the devices managed? Any device can be a controller. In Ansible, with Chef, the Chef Master, Puppet, the Puppet Master, Salt, the Salt Master. What's created by the tool? Playbooks for Ansible, cookbooks for Chef. Puppet is a manifest, and Salt Stack is a pillar. IBM and Cisco DNA Center. What do we got? It's like 11:55. Do you want to break now for lunch, or you want to break after?
Break now.
So
Break
11:50,
now.
1:10, we're back. Okay? We're
All right.
much more left to it. But break now for lunch, and at 1:10, we're back. Everybody good with that?
Yeah.
Okay, lunch till
Yeah.
1:10.